Graphing quadratics using the step method with an explanation of vertex form. I'm going to explain the vertex form of the parabola, which is y equals a, x minus h all squared plus k, piece by piece, starting with its simplest form, which is y equals x squared. I'm going to use a table of values, starting with 0 in the middle, going up by 1, and going back by 1. If I sub into my formula, sub in 0 for x, it becomes 1. If I sub in 1 for x, it becomes 1. And if I sub in negative 1 for x, it also becomes positive 1. That's the nature of a quadratic. Subbing in 2, I'll get positive 4. Subbing negative 2 in, I'll also get positive 4. Positive 9, positive 9. Plot my coordinates, 0, 0, 1 over 1 up, 2 over 4 up, 3 over 9 up. The quadratic is symmetrical, so it's the same on both sides. Just follow the pattern. And there is y equals x squared. That's known as the parent parabola. That's the parabola that every other parabola is compared to. On the right-hand side, same equation, only with a negative in front. Again, I'll use the same x values, stepping up by 1, stepping back by 1. But now when I sub in, it's slightly different. 0 squared is still 0. Y equals negative 1 squared. Negative 1 squared is positive 1, but with the negative sign in front, it becomes negative 1. Negative 1 squared is also negative 1. Hopefully you can now see that the values will be the same as before, only with a negative value up front because of how the equation is written. So I start with 0, 0, 1 over 1 down, 2 over 4 down, 3 over 9 down. But because of the symmetrical nature of the parabola, I can simply mirror my coordinates. And now I have the parent parabola reflected like a mirror over the x-axis. So some more qualities to a quadratic. The vertex is that coordinate in the center. So looking at the parent, the original, the vertex is 0, 0. It opens up. So the vertex itself being at the bottom means it's the smallest value. The axis of symmetry is the line that cuts the parabola in two, in which case that would be x equals 0. So the axis of symmetry is x equals 0. The domain, because a parabola continually widens from left to right, is the set of real numbers. The range, again, belongs to the set of real numbers, but y is equal to or greater than 0. Translation means how is it different than the original? And in this case, there is no translation, so there's none to report. Now, if I'm looking at my red parabola, which now opens down, a few things change. The vertex is still 0, 0. Axis of symmetry is the same. The range is slightly different, and the translation is slightly different. So in this case, it opens down, which means that our vertex is at the very top or the maximum value. y is equal to or less than 0. And the translation is that it's reflected over the x-axis. We're now going to move on describing the quadratic and vertex form by adding a. So I have two examples, same numbers. One set is positive and the other set is negative. So starting with y equals 2x squared, same values for x, step it up 1 from 0 and step it back from 0. If I sub in 0, I will get 0, 0. Subbing in 1 results in 1 squared is 1, 2 times 1 is 2. Subbing in 2, 2 squared is 4, 2 times 4 is 8. And subbing in 3, 3 squared is 9, 2 times 9 is 18. You know from our previous examples that the numbers on the negative side, because of the nature of squaring a number, result in the same values. On the negative side, I hope you remember that all that is different is that the values now become negative for y. -1, -2, -3, switch the values. And now when I graph my positive parabola, instead of 1 over 1 up, I'll go 1 over and 2 up, 2 over and then 8. I can't go any further because I've run out of graph, but because of the axis of symmetry, it's very easy to plot the other coordinates. And now I have y equals 2x squared. The opposite is true when you have the negative 2x. And again, I'm just going to plot them quickly. And that one is going to open down. Looking at the vertex of the positive value, it's 0, 0. My pink parabola opens up. My vertex is at the bottom, so it's a minimum. Axis of symmetry, the line down the center, is x equals 0. The domain is always going to be a set of real numbers for a parabola, and the range is going to be greater than or equal to 0. The translation now gets interesting. It's not the same as the original. It's opening up, so the only difference is that it's tall or skinnier. So when we're talking about parabolas, we're talking about stretching it. So it's stretched by a factor of 2. Okay, so that is the translation. Really important to be able to describe the parabola. When we're looking at the purple, the vertex is the same. It's opening down and it's a maximum. Axis of symmetry, identical. Domain, identical. The difference here, it is now less than or equal to 0. It's stretched by a factor of 2, but it's reflected over the x-axis. See if I can squeeze that in there, over the x-axis. When we're looking at 1/2 of x squared, again we will use the same values, 1, 2, 3, and step it back. It's still 0, 0. 1/2 of 1 squared is 1/2. 2 squared is 4, 1/2 of 4 is 2. 3 squared is 9, 1/2 of 9 is 4.5. And the numbers are identical going this direction. So now 0, 0, 1 over 1/2 up 2 over 2 up, 3 over 4.5 up. Use your axis of symmetry. And now your parabola is now outside of the original. Just going to highlight the original in black here so you can see it perhaps a little more clearly. There's the original parabola. And now if you're looking to describe the orange one, it's fairly close to the pink, only it's outside of the original. So we describe it slightly differently. So the vertex is still 0, 0. It's opening up. Therefore, the vertex is the least, the minimum. Symmetry is the same. Y is greater than or equal to 0. The translation is now compressed. So when something is outside of the original, it's compressed or flattened. Compressed by a factor of 1/2. I'm going to erase a bit of this just so we can get a little bit clearer. There's the original. If I were to put the half back, it would be 1/2, it would be 2, it would be 4.5, 1/2, 2, 4.5. There's a 1/2 x squared. And if I were to fill in that table of values on the negative side, it would simply reverse it. So this parabola is the opposite. It would be down, it would be a maximum. This would be reversed. This would be identical. Might as well make it blue so you can see it. And the only difference would be that it's reflected over the x-axis. So when we're talking about A, we now know that when A is positive, it's up. When A is negative, it's down. When A is greater than 1, it's stretched. And when A is less than 1, it's compressed. Moving on, we're going to increase our fraction of A. So y equals ax squared plus k. I have 2 examples. We'll start again with easy values for x, stepping away from 0 on either side 3 times by 1s. Subbing in, y equals -2. I'll start with a larger value first, plus 8. 3 squared is 9. -2 times 9 is -18. Plus 8 is -10. Subbing in 2. 2 squared is 4. -2 times 4 is -8. Plus 8 is 0. Subbing in 1. 1 squared is 1. -2 times 1 is -2. Plus 8 is 6. And if I sub in 0, I'll get 8. So our new vertex is 0, 8. Plug in our values, 1, 6, using the mirroring effect, 2, 0, 3, -10. Using the axis of symmetry and the mirroring effect makes it fairly quick to graph once you have your coordinates. Your vertex is now 0, 0. It opens down, so it's a maximum. We're talking about the vertex. Axis of symmetry is still the same. Y is equal to or less than 8. The translation, it's up 8, and then it is stretched by a factor of 2. Factor of 2, and it's reflected over the x-axis. next example is positive. Again, I'll start with 0 in the middle, stepping away by 1s 3 times. I'll do this completely verbally this time. 0 squared is 0, half of 0 is 0, minus 5 is negative 5. 1 squared is 1, half of 1 is a half. A half minus 5 is negative 4.5. 2 squared is 4, half of 4 is 2. 2 minus 5 is negative 3. 3 squared is 9, half of 9 is 4.5. 4.5 minus 5 is negative a half. I'm going to clear out some space to graph it and get rid of our analysis here at the bottom. So 0, negative 5 is our starting point. 1 over, and that is negative 4.5. 2 over, and it's negative 3. 3 over, and it's down a half. And there is my new parabola. The vertex is now 0, negative 5. It opens up, so it is a minimum. Again, we're talking about the vertex here. Axis of symmetry is 0. In this case, y is equal to or greater than negative 5. The translation is down 5. Compressed by a factor of 1/2. And now we know that k moves the parabola up or down. A shows direction. If it's positive, it opens up. If it's negative, it opens down. And we know that if the number is bigger than 1, it's stretched. If it's less than 1, it's compressed. So putting this information now together in a bit of a picture, we now, again, I'm going to repeat, A, if it's positive, opens up, and if it's negative, opens down. K moves the parabola either up or down depending on the number. A's got a complicated job to do, so I like to use a number line to show what A does. So when A is between the ones, it is going to be compressed. If A is greater than 1, it's going to be stretched. If A is on the ones, it's going to be congruent, which is a fancy word for meaning the same as. So if A equals 1, it's the same as the original. The only thing A cannot be, and which is why we have an open circle here, is A can't be 0. You might realize that if A were 0, you no longer have a parabola, you have a line. So all we have left to figure out now is what does H do? And now we're going to use the entire vertex form of the quadratic. So looking at our first example and using our normal x value, stepping away from 0 3 times to the right, 3 times to the left. When I do the calculations, you're going to notice that the numbers no longer mirror each other. And when you go to graph it, those two are way off my chart. I can guesstimate 1 and 12, then I'm going to get 0, 5, negative 1, 0, 2, negative 3, negative 3, 4. I don't actually have enough information to know where the vertex is. It's over here somewhere. I'm just not sure exactly where it is. The same can be said for my other example when I step away from 0 3 times. My numbers won't mirror. And that makes this a very unuseful way to chart a parabola. So I can do 3, 4, and I can do 2, negative 1, and 1, negative 8. Then after that, my numbers aren't that useful. So I know it's going to open down, and I know that my turnaround point is up here somewhere. But using the chart in this way isn't going to help us. So I'm just going to erase what I've done on the graph and show you how to use the chart in a more effective way. So what I haven't explained yet is that the vertex, that middle value in the formula, is denoted by h and k. So in our initial positive example, the vertex is negative 3, negative 4. And in my negative example, the vertex is 5 and 8. So now when I step away from the vertex to the positive side 3 times and to the negative side 3 times, when I go to put my numbers in, 0 plus 3 is 3, 3 squared is 9, 9 minus 4 is 5. Negative 6 plus 3 is 3, 3 squared is 9, 9 minus 4 is 5. Now my numbers are going to mirror each other. And now when I go to graph it, negative 3, negative 4 is my vertex. Negative 2, negative 3, use symmetry. Negative 1, 0, again use symmetry. And 0, 5. And now I can use my chart to graph my parabola. What you want to do is be able to identify h and k as the vertex and then step 2 or 3 values on either side. The same will be true with my other example. So 5, 6, 7, 8, stepping 3 up and 3 away. And when I sub in my values, they will mirror each other. So 5 and 8 is my vertex. 6 and 7. 7 and 4. And 8 and negative 1. And again, I'm able to do it quickly using my axis of symmetry. So starting with my pink one, the vertex is now 5 and 8. It opens down, so my vertex is a maximum. Axis of symmetry is now changed. The axis of symmetry is the x value, so x equals 5. The range is as x is equal to and less than 8. The translation is that it is to the right, I'll use short form, to the right 5, up 8. It's reflected over the x-axis and is congruent to the original. You'll notice that A is simply negative 1. So your translation is that it's simply reflected over the x-axis. Erasing this now to describe my orange parabola. The vertex is negative 3, negative 4. This one opens up, so the vertex is the smallest value. The axis of symmetry is x equals negative 3. And the domain is equal to or greater than negative 4. Translation, to the left 3, down 4, and that's all. Because A is 1, it hasn't changed from the original. So talking just about the vertex, if you look at your equations and think of flipping h and keeping k, you should get it right each time. And by flipping h, I mean changing its sign. And the reason it works this way is because h has a negative sign in front of it. So if I sub in negative 3, 5 for h and k, here's what happens. I get x minus h is negative 3 and k is 5. When I tidy it up, it becomes positive 3 plus 5. Thus, you have to flip h or change its sign. If I do the same to the opposite example, sub in 3 for h, you'll notice that you flip h to get back to the vertex. Now we know what all the letters in the vertex form of quadratic mean. We know that A tells us whether the parabola opens up or down. If it's positive, it opens up. If it's negative, it opens down. If the A value is between the ones, we know that the parabola will be compressed. If A is greater than 1, whether it's positive or negative, the parabola will be stretched. We know that if A equals 1, whether positive or negative, it will be congruent. And these three words are describing the parabola as it's compared to the original y equals x squared. The only thing A can't be and have it be a parabola is it can't be 0, because then it would be a line. We know that h and k is the vertex, and that they are special values of x and y. To easily tell what the vertex is, flip h or change its sign and keep k. Just a reminder that x and y are an infinite number of possible coordinates. So very quickly, identify the vertex in each equation. Flip h, keep k. Flip h, keep k. If there's no h, the value is 0. If there's no h or k, it's 0, 0. Flip h, no k. Flip h, keep k. So there are a few ways to graph a parabola. the one that I just showed you involved creating a table of values starting with the vertex. So there's your vertex. You're going to step to the right 3 times and step to the left 3 times. Filling in the table of values takes a bit of mental math, but it can be done. And then you would simply plot those coordinates. There is a quicker way, and that is using something called the step method. Here's your original table of values for y equals x squared. The steps of y equals x squared will be 1, 3, and 5. That's the difference between each of the original values. And it's the same if you go to the right or to the left. It's 1, 3, and 5. So if I were to graph that, I would start with 0, 0, 1 over, step 1 up, 1 over, step 3 up, 1 over, step 5 up. So your steps are 1, 3, and 5. And it's the same on the left-hand side as it is on the right. So those are the original values of the parent parabola. So there's no need to plug in numbers for y equals x squared if you remember the steps are 1, 3, 5. So using that same technique now, I can graph any parabola I want. So I use my a value, which is 2 in this case, and I multiply the steps by 2. I plot my vertex, which is 5, negative 4. Flip, keep. 1 over step 2. 1 over step 6. 1 over step 10 will take me off my chart. The same as on the left, 1 over step 2, 1 over step 6, 1 over step 10. So in each case, you're stepping from point to point, just like a staircase. And then you can graph your parabola. So plot the vertex and pretend it's 0, 0. Multiply 1, 3, 5 by whatever value a is. Step point to point using your new pattern. And just remember it's 1 over step, 1 over step, 1 over step on both sides. An alternative way is graphing from the vertex. It's very similar to what we just did. I can start with my vertex, which is 5, negative 4. And again, I can fill in the chart by stepping 3 times, 1 each way. The numbers will be the same, and you can certainly graph using a series of coordinates. When you graph from the vertex, you're still going to use your a value, and you're going to multiply, this time, the original y values from y equals x squared. And really, it's just a different way of stepping. Our vertex is still 5, negative 4. To the right 1, up 2. To the right 2, up 8. To the right 3, up 18. So instead of using 1, 3, 5, you're using 1, 4, 9. And instead of going from step to step, you are going from the vertex each and every time. And as you can see, it's exactly the same parabola. Very similar steps. Plot the vertex, pretend it's 0, 0. Instead of multiplying 1, 3, 5, you're going to multiply 1, 4, 9. Step from the vertex, and just remember it's over 1, over 2, over 3. Always from the vertex. 2 examples using the step method and remembering 1, 3, 5. So in this case, my vertex is flipped and kept, -2, 3. -2, 3. My pattern is 1, 3, 5. I'm multiplying by a, which is -1/2. So it's -1/2, -1.5, and -2.5. Step to the right, down 1/2. Step to the right, down 1.5. Step to the right, down 2.5. Step to the left, down 1/2. Step to the left, down 1.5. Step to the left, down 2.5. And there is my parabola. On the other side, my vertex is flipped and kept. So 7, -6. The a value is 1, so my pattern doesn't change. Step to the right, up 1. Step to the right, up 3. Step to the right, up 5. Step to the left, up 1. Step to the left, up 3. Step to the left, up 5. And there's my parabola. Again, you plot the vertex and pretend it's 0, 0. Multiply 1, 3, 5 by a. Step point to point using your new pattern. Remember, it's over 1 step, over 1 step, over 1 step, both sides. The alternative is using 1, 4, 9. So in this case, a equals -1/2, and your vertex, -2, +3. So 1, 4, 5 becomes -1/2, -2, -4.5. And you're going from the vertex. So step to the right, down 1/2. Step to the right twice, down 2. Step to the right 3 times, down 4.5. You can use your axis of symmetry at this point. And there is your parabola. One thing that's nice about using 1, 4, and 9, always coming from the vertex, your fractions might be a little more accurate. The other side now, a equals 1, and your vertex flipped and kept. 7, -6, and it's 1, 4, 9. Step to the right, 1 up. Step twice, 4 up. Step 3 times, and it is 9 up. Again, you can use the axis of symmetry as your friend. Plot your points fairly quickly after you get the first side done. And there's your parabola. Plot the vertex, pretend it's 0, 0. Multiply the y pattern by a. Step from the vertex each time, over 1 up, over 2 up, over 3 up, both sides. Hope you learned something. Thank you for watching.